Hey everybody, this is Brad Doug reaching out to you to say hi, and today we're going to talk about a cool, fun topic. So, this topic, sorry for walking away from the microphone, but this topic is a really cool one because it's going to talk about a project I have coming, and just to let you guys know. So, there's going to be a day in your life, in your small home lab, that you're going to need a box, a Rio box. Or, more importantly, you've decided that Windows whatever version ain't going to do it no more. I need power. I need to go SMP. Now, SMP means symmetric multiprocessing, or 2 processors or more on my motherboard. Now, if any of you professionals know how wonderful it is to try to get Windows to use the advanced and more capable features of things like 10 gig NICs and CPUs and RAM pools and so on, you will know that nightmare very well, because Windows is designed for the common and not for the proficient. It has no algorithms out there designed to say, oh, look, you've got more than one processor. No, you actually have to go in and make physical changes to your configurations to truly try to maximize the effects of Windows to take advantage of everything you've got. And what end up happening is pretty much still a slightly hampered system. So I had gotten fed up with it a few years back, and I said, enough. I mean, I always support Windows, don't get me wrong, but it's time for me to move to Xeon. Oops, sorry. It's my favorite processor. It's a Pro 6. Come on. I mean, these things were so freaking awesome back in the day. But Xeon, baby, time to go multiprocessing. Now, obviously, to truly use a multiprocessing stack, you have to have memory. Lots of it. 46, 48 gigs or more. Minimum, I would say. The reason why I picked that number is ranged by the amount of hypercore processors you have versus your actual core processors. To take advantage of your systems and to build a truly dynamic environment, you need to scale. To scale, you need memory. So that's the most important thing. Now, communication, like your network connections, that's important too, but we'll talk to that later. So you want to go Xeon. So there are some lessons to learn here about Xeon. First things first, you don't need to buy brand new. I wouldn't. Matter of fact, you really need to do your research first. There are, like everything else out there you will see from me, make and model is the right approach every single time. In other words, if you have a piece of hardware that you are looking at, you better do your research to find out if that system is what it's supposed to be and what you need. And I mean specifically that, buying a $1,000 motherboard and 2 $1,000 processors could have easily been done in $300. All of it for $300, including the RAM. So, with that being said, let's think about this out a little bit outside the box. So, Xeons. Xeons are very powerful processors, designed to do more than a single attribute configuration system. In other words, it's going to do more than you just playing a game. It's designed to run stats. It's designed to do a database. It might be doing virtualization. It could be handling your storage pools. It could be segregating your networks if you want it, and so on and so on. It's a server. It serves out to everything out there. Or it processes heavy data workloads, such as codexing, as a good example. And these offer a vision or a scope of what you might want. So for all of you audio people out there, and for all of you video people out there, you are all interested in crunching numbers, data, basically, compressing data, reconstructing data into other codexes, and so on and so on. Xeons are absolutely spot on. Can you still play your games? Can you still do all the other stuff and read your email? Shh. You sure can. I do it all the time. I have 48 core processors. Actually, correction, I did. Now I have 56 core processors because I switched out the processors with 2 new upgrades. And I am codexing video for MP4s. And I'm working my email, and I got a little game of Command and Conquer going on. And I've got some stats compilers out there generating some numbers off of websites. I'm doing this all on a multi-Xeon that's 6 years old. Age. Xeons don't follow the same genre as i5s and i7 generational standalone processors. That's basically these guys. Now, don't make a mistake. You can buy i5 multiprocessor motherboards and i7 multiprocessor motherboards, but they're still principally the core board, using a divide clock process to share the resources between the actual memory units itself. Or they degrade the ability of your memory scope, because they'll take 2 of your 4 slots for CPU 1, 2 of your 4 slots for CPU 2, and suddenly you're having to buy 2 blocks of 64 gigs to get enough memory to do what you want to do. That's not the same thing as a Xeon SMP motherboard. There are Xeon SMP motherboards that will fit in a standard ATX case, and they'll do just fine. I know, because I did a video about 4 or 5 weeks ago on moving my ATX Xeon dual motherboard into a new full tower case ATX wise, and it had all the bells and all the whistles, and I was able to do quite a bit, and it was all still in the ATX format. So that's the second step. Know your processor first, what you need. Secondly, know your format. Now, you do have Xeons, mostly single mode Xeons, that can fit into smaller cases. That requires that you buy a bigger processor core-wise. And again, your memory is going to be more costly because you're in a small format, so you're only going to have 4 DIMM slots, 2 at the minimum. But Xeons are compatible and they can run. Not recommended. You're not getting the full value of a Xeon. Not yet. Stick with me, I'll explain. Now, the other thing is, once you've written the list of what you want to do, what you need to do, and you want to do it faster, and you're tired of waiting for these jobs to finish and so on, the Xeon brings to the equation what you need. The next thing, believe it or not, these days is a GPU. Now, not necessarily a GPU for gameplay, which is good, by the way, but actually, if you wanted, a GPU focused on your AI. So, for instance, you put Docker on your workstation, because that makes perfect sense to me. You want to virtualize. You want to build containers. Well, let's say you want to do a JAT-PT AI installation onto a couple of virtual machines and containers, and you're going to use Docker and so on and so on. Having a GPU compatible Xeon motherboard for the past 5-6 years, no problem. Matter of fact, some of these proprietary Xeons can now do GPUs, which is really, really beneficial, because if you know anything about a 2U case, they're not very friendly. And the 4Us are better because they don't require the small form factor. They have space, so you can actually put a normal power supply in, and you can provide power for the GPUs indirectly, and that's fine. But the motherboard that I'm bringing soon, which I'll be doing a video on, is a composite set motherboard. In other words, it comes in a couple pieces. And I want to do that for a ZFS demonstration. I'm going to do it as a video. And I got what's called an open format case. And it's got dual power supplies, which I'll cover all of that good stuff. And it's a real, true, genuine SMP motherboard. Do you need any of all that? No, you don't. So don't look for the 2Us and the 4Us. Look for a mid-size case, minimum. Full-size case is better, because you've got some breathing space. ATX motherboard, dual Xeon motherboard class, SMP classification, 8 to 12 or 24 memory slots, depending on what your wishes are. Mine, usually 8 is fine. You want to get the latest PCI generation that you can. Gen 3 is the one is preferred. If you can get a Gen 4, that'll be like 3 or 4 years old. Try. It's experimental. You have to be careful with that, because a lot of motherboards that says they're PCIe 4 ready means their BIOSes are not. So you have to pay attention. There's a lot of out there you don't want to play with. Gen 3s are the way to go for the most part. Extended functionalities that might get you excited. I can tell you this, believe it or not, it's okay. Why don't have M2s on the motherboards? Because M2s for servers weren't feasible until recently. So you're saying, well, darn, that means I can't do M2 NVMe. Sure you can. Absolutely. Not only can you do that, oh, good Lord, can you do it? Because NVMe, ladies and gentlemen, can go directly on the PCIe bus. There you go. There's an NVMe right there. You can put 2 of these in if you want, if you really want to. Or better yet, you can get your hands on one of these guys. And you do notice, though, I do remind you that it's on a PCIe 16.8. That means that's a 16-edge connector, but it is an 8. But you can get them. They exist. You can also pair up SATA NVMe and M2 NVMe. And yeah, there is a difference. One actually requires that you connect a SATA cable to the PCI card for the second NVMe that you've got in there that's compatible with that edge selection. I've got a card out here somewhere. I can't find it, but it does just that. I've never used it because what's the point? I mean, I could just use a simple SSD, SATA drive, right? To take care of that. But the key thing is, you can do NVMe. Absolutely. No problems whatsoever. And they have 4 and they have 8. I'm currently running really great on an NVMe on my 6-year-old motherboard. That's a dual Xeon 2490 series version 4 stack. And that is a house of cards when it comes to cores. So those 58 cores that I've got out there at my disposal to work with, which is just incredible. It's just awesome. I love it. I can't get enough of it. I can do anything. I never run out of resources. And the fact that I've got, 84 gigs of RAM allows a lot that to happen. So that's the other value. So with that, getting yourself a semi-old Xeon could cost you $50. A Xeon motherboard. I just today bought myself a Gen 12 chassis from Supermicro. It's an X6103 series. It's on the chipset C612, I think. I'm doing this off of memory, so please forgive me. And it's got all the makings that I want to do for a ZFS array, and would co-support the functionality of doing some JetTP, or whatever they're called, the AI, the chat AI engine, which is the common one, the popular one today. And I'm looking at saying, can I have one housing, not a motherboard and processor, but can I have an entire case that's got everything I need in it, from AI all the way to adaptive RAID storage? Not that easy, if you really want to know the truth. Now, what else can I do with this? Well, ladies and gentlemen, I can put SAS 12 gigabytes into the equation. Not gigabits, gigabytes. That's SAS. Okay, that's dual inline memory processing for hard drive write sequencing and read. In other words, dual data pathways, not single pathway like SATA. SAS is powerful. Even when you don't have spinning disks and you're using SSD drives, boy, does the SSD come back and just let you know. You got to understand something about SSD drives. NVMEs will saturate your bus on your PCIe. They will take every ounce of what you got. SATA SSD drives will do the same thing. So I've always preached, don't put a lot of SSD SATA disks in large groups. Don't do that, because you're just wasting money. Put them in smaller groups and keep the channels segregated, because you'll max out your controller's bandwidth on each of those channels, and that's what you want. Once you get to a certain point, you have a negative effect that actually starts slowing down your write cycles. You don't want that. You want to keep going forward. So, if you've got yourself a full-size tower, right, and it's got 6 bays in it, for SSD drives or whatever drives you have. You bring in a 12 gig SAS card, which will be, I think, the LSI 120 series, not the 93s or the 9200 series. But I'll have to double check. I'll put the link in the down below to confirm. And with that, I also am going to bridge SAS. Now you're thinking, what do you mean? Well, you have to understand. You see, SATA is SATA, and 12 gigabit SAS is. Hold on a second here. I'll show you. Is not SAS. Okay, you see that? That's 2-edge connector right there. We can see that. There you go. So, but what SAS is let's see. Yeah, there you go. SAS is this. 6 gigabit SAS. That's what that connector looks like, opposed to a 12 gigabit SAS. Now, it's pretty obvious what you're seeing here. 2-edge connectors versus one. That's not as big as the other one. And so what they've done is they parsed out the pipe so that they can create a larger dual pathway. Now, I'm going to go from this connector to a 12 gigabit LSI RAID controller. So I can do that with this system because I've got the slots for it, and it is a very nice adaptation you can do for ZFS arrays for like TrueNAS and so on. And you still haven't spent much money because I just bought that 12 gig card for $18. So let's go back over my price tag here. I bought two processors, $7 each. Okay, for that dual processor motherboard. I bought 64 gigs of RAM to outfit 32 gigs per each of them, so I could do some core testing. But it would be more efficient if there were 64 each. And I've got two separate buses, one on the left and one on the right channel, called channel A and B. And they each have their own independent 16 gigabit down, 16x PCIe port down on both sides, and I only need 2 ports on each side, but I actually got one extra. So I can actually put a GPU in there as well as my 12 gig SAS and my NVMe and so on. So with that, and by the way you would do that is I would take my A channel, read the manual of your motherboard. It will help you identify which one controls the NVMe value for your bus. It's usually the A channel, but you should double check. Go to the A channel and you put your NVMe card in the designated slot the motherboard tells you to put it in. It doesn't. Not every port does what it's supposed to do. It might be bigger, but they don't necessarily have all the connectivity. Only one will be a true 16X. So you're going to put this guy in that proper port. He's going to take up a whole boatload of bandwidth. If it's Gen 3 and down, that's an 8X bandwidth loop. Gen 4s and Gen 5s can absorb a lot more. Then I go to channel B and I'll put like a small Quadro Pro NVIDIA processor GPU card in. It's not going to do video. It's just going to be out there as an available GPU for our AI resources to use for a chat, I forgot what it's called, chat TP, whatever it's called, for its functionality. So now I've got a GPU in there with its open-ended architecture processing, and of course I've got my CPUs for the multi-cores that I need for doing the CPU functionality as well. Now on top of that, I'm going to put my SAS 12 gig card along with that GPU because they don't take up that much traffic. The GPU is a little older card, so it's never going to go beyond 8X, and a 16 bridge connection basically for a 8X style connection for the LSI 120 series 12 gig card won't require much either. So I just plug those guys up. But one thing I do need to do, and lo and behold, on this particular Xeon motherboard case I picked, I'm getting power right off the motherboard to power the GPU. I don't need to plug into the power supply. See what I mean? You can do this too. The case is really cool. It's adaptive, but it's not 100% adaptive. Unlike that case back there where I did my video, the white one in my tower rack there, that's 100% adaptable. This one's more about 60% adaptable. And I opted for the dual power supply because if this pans out to be a good Proxmox engine, is what I'm doing basically, I'm gonna probably put this guy online within my Proxmox cluster so that I can have an actual GPU resource in my Proxmox cluster, which is not normal. So I have 4 chassis in here that can support GPU as part of their design. The remaining ones don't, which means I'll have to hodgepodge a split or a splice, source out a power feed, and use that to provide power to a GPU, which kind of gets kludgy. It's pretty tight in there. So when you have to do that, you have to do some really interesting planning and cutting and snipping and shortening things and growing things as you need to have fit. So that's why going ATX is a great option for a Xeon. Like I said, I'll put the link into the chassis I bought, and it's for the Proxmox design. It's not for workstation functionality. But if you look in my videos, last, I think, late November, early December, I did the video on my how I transitioned my dual Xeon, because it's still such a great motherboard, over into a brand new case, full size case, and it's 100% compatible. I brought that bad boy over, and it was operational, and it was good, and it was just a matter of a few small tweaks, cable management, some cleanup, and I was back and running that same evening. I can't say that for these guys. It takes a few weeks to get that going. But look for that video to come soon about the new chassis, which I'm looking into designing and getting in place. And I think I'm going to put that bad boy, it's a 2U, probably down on the bottom part down here where you can't see it. And I'll have it placed in, I could also put it up there on above the white chassis. I don't know yet, we'll figure that out. The key thing is we're going to be able to have some play with it. You're going to see me build it from scratch. It's gutted, and it's another one of those examples of going out there and getting manufacturer's warranty equipment that was put aside to support warranty replacements. And now that that equipment is no longer in warranty, they have to sell all that surplus off. So I cheated. I am getting all brand new gear, basically. No, it's a couple years old. So what? It's brand spanking new. And that being the case, you get away with a tremendous amount of savings, because I've only spent $290 so far, and I'm building a system, a Xeon dual processor platform system, for far less than buying one of those little thin clients up on the top shelf you see behind me, which usually go for about $450, between $320 and $450. So that's telling you something. Well, that's it for me today. I'm going to be letting you guys go. God bless, and please have a blessed year. Christmas has passed, and now we're at the post-Christmas, pre-New Year's Eve. And as always, please don't drink a lot, drive safe, and always be cautious of the people around you. Celebrate with joy and safety and caution, and have a wonderful beginning of a new year. I'll let you goodbye. Bye-bye. God bless.